Hello everyone. In this video, we are going to see a question that is based on, you can say, behavior of inductor, capacitor, and Thevenin's theorem, and transient analysis. Okay, so this question will be a mixture of, you can say, all of them. You have given one linear network, and the voltage source, the voltage that you are applying, it is 40 volt, and current that is coming out from the source is 2 ampere, and let's say this is my load resistance is 3 ohm, and current flowing through the uh, through the resistance is 2 ampere. Actually there is a issue here. You should take it as a maybe zero point 0.5 ampere. Yeah, because if 2 ampere is coming from here and 2 ampere is going into the 3 ampere 3 ohm, that means it is a series connection. It will show in the linear network inside this black box. So to have a much more clarity, we can have this current 2 ampere and this current as 0.5 ampere. Okay, and what you are doing, uh, uh, the same network, you have the same network here as well, but you are performing two switching actions, and the network has load is still 3 ohm, and you have to find out the current I of t. So what it is given, like the initial voltage of the capacitor is 20 volt. That means the initial value of this initial voltage across this capacitor is 20 volt. Okay, and S1 is closed at t equal to 0 and remain closed till till pi seconds. Okay, that means initially this S1 switch is closed for pi duration, but still my S2 is open. Okay, and at pi second you are opening the switch S1 and you are closing the switch S2. You have to find out the current I of t at 2 pi second. So how to proceed with that? Basically, in such complex problem, whenever you see the load resistance is same for both the network, both the combinations, uh, you can go with the Thevenin model. Okay, because if you see from this point and if you see from this particular terminal, you can say both the network is same. Okay, so I can calculate the Thevenin resistance looking from this terminal, that is, or the R input resistance is 40 by 2, it is what, 20 ohm. So R input is 20 ohm. Okay, now I will analyze the from 0 to pi second now, because till pi second only S1 is closed, S1 is open. So I will analyze the things from 0 to t to pi second. Okay, so what you have capacitor and you have inductor. This capacitor has initial voltage of 20 volt. This is 1 farad and this is 1 Henry. This is a LC circuit, LC oscillator, and the frequency of oscillation of this particular circuit is omega is equals to 1 by root over LC, that is 1 radian per second. Okay, now for a LC circuit, you must know how to calculate voltage, currents, and all. Maybe I can give you brief idea about that. For that, we need to take help of Laplace transformation. So if you transform this particular circuit in Laplace domain, you will get 1 by S, 1 by Cs basically for capacitor in the S domain. This is the voltage source, the initial voltage. This is 20 by S. Okay, I'm not going much detail how it came, and this is SL, and here C and L is 1, so I'm just removing the C and L term. And let's say I want to calculate the current I of S. Okay, so current I of S is simply 20 by S, 1 by S plus S. Okay, so 20 1 plus S square. Okay, so what you will get, 1 by S square plus 1. So if you take the inverse Laplace, you will get 20 sine t, right? This is the thing that you will get. So now I know the current that is flowing in the inductor, that is I of t, and the I of t is simply 20 sine of t. Okay. Mm, yes, I know this IFT current. Now, this particular circuit is valid. Let's say this is my time scale, and till 0 to pi second, my S1 was closed. Okay, but after that, from pi to till infinite duration, my S2 was closed. This is for S1, this is my S2. Okay, now I am performing switching action at t equal to pi second. So if I calculate the current of inductor at pi second, that is I of pi is equals to 20 sine pi. So it says the current at pi duration it is 20 sine pi. It is simply uh, omega t. See pi radian per second, right? So here omega equals to 1 and t equal to pi. So at sine pi actually it is value 0. So this current will be simply 0. So that means in this case what is happening? If you open the switch and if you close the switch S2, and at that moment inductor current is 0, so no current will flow in the circuit. Okay, but let me consider one maybe another instant. uh, Maybe I can consider I am closing the switch. Maybe let me take a different instant that will make the problem more interesting. Let's say this instant is pi by 3, and this is also pi by 3. So what is happening? Like initial voltage of the capacitor is 20 volt, and S1 is closed at t equal to 0 and remain closed till pi by 3 second. So this is pi by 3, and this is pi by 3. Now I am performing switching action at t equal to pi by 3 instant. So if you put pi by 3 here, what you will get? You will get sine answer into 20. So you will get 17 point I of pi by 3. It is 17.32 ampere. Okay. So if you also see the current and voltage expression, let's say this is my voltage of the inductor. So voltage across inductor, it will be a capacity a cosine wave. Okay, but for the current waveform, it will be sinusoidal in nature. Okay, it will be sinusoidal in nature, and at this value, it is pi by 2. It will have maximum value of the current. This is my I of t, but I am performing switching action at pi by 3, so it will be less than 20. So here it will be 17.32. Okay. Now my current has initial current of 17.32, and if I open this particular switch and if I close this particular switch, the equivalent circuit will look like this is my inductor, this is my one resistance of 2 ohm, this is my circuit, the linear network, and this is my 3 ohm, 2 ohm, 1 Henry, and it has some initial current, let's say at I pi by 3. It has in some initial current. So because of this current, you will get some current here also. But initially, if I consider only t equal to pi second, in that case no current will flow, and you will not get the flavor of this particular question. So I just change the time instant here. Now I know the Thevenin equivalent or the input impedance, that is 20 ohm. So let me rearrange the circuit. So this is my inductor, this is my 2 ohm, and this is my what 40 ohm, 20 ohm, right? 20 ohm. This is my 20 ohm. This is my R input, okay? Input resistance. This is my 2 ohm, and this is my 1 Henry. It has some initial current, let's say I. It has some initial current I. So so if you write the current expression of it is a RL circuit without excitation. Okay, so the current expression for a RL circuit is simply uh, you can can say, maybe I can write the entire expression I infinity plus I of mm, I of pi by 3 plus minus I of infinity e to the power minus uh, t minus pi by 3 by tau. In general, we don't write this pi by 3 and pi by 3, and like we generally we write this kind of equation I of infinity plus I of 0 plus minus I of infinity e to the minus t by tau. See, this particular equation is valid only when you are performing switching action at t equal to 0. But there is some delay in our case. So that's why you have to show the delay by subtracting pi by 3 from t. Then only you will get this particular relationship. Okay. Now, I infinity, it is a source free circuit. So I infinity will simply 0. Okay. But it has some initial value, and let's say this initial value is I pi by 3 plus e to the power minus t minus pi by 3 by tau. Tau of the circuit is L by R 1 by 22. So, and I pi by 3 is simply 17.32, right? 17.32 e to the power minus 22 t minus pi by 3. So this is the equation you have for the current I of t. Now, I know this particular current I of t, but in the question it is asked to calculate this current I of t. So let me give name it as IL of t, otherwise it will be complex to understand. So the inductor current ILT is given. So what I know, so this was my circuit, 3 ohm. I need to find out this current. I know this current IL of t. So now we have to take help of you can say the linearity theorem. It says when 2 ampere current is entering the linear circuit, and I am getting 0.5 ampere at the output. So for 2 ampere input current, the output current is 0.5 ampere, and this current is flowing in the you can say downward direction, but the 2 ampere I have considered it was flowing in this direction. So with respect to this, it should be minus, right? So for minus 17.32 e to the power minus 22 t minus pi by 3, what is the current that you need to find out? Okay, so the current that will flow in the circuit will be I by 2 is equals to minus 17.32 by 2 into 0.5 e to the power minus 22 t minus pi by 3. Okay, so this will be your current. Okay, 17.32 into 0.5 by 2, so we are getting minus 4.33 e to the power minus 22 t minus pi by 3. We have to calculate the current at t at, you can say, maybe I can erase this portion, at t equal to 2 by t equal to 2 pi, right? So if I just put t equal to 2 pi, what you will get? Minus 4.33 it the minus 22, uh, so it will be 2 pi minus pi by 3, 2 pi mm, minus pi by 3 into 22 e to the power minus answer into 4.33. It is a very less value is coming, minus 4.067 into e to the power 10 to the power minus 50 ampere. See, this current value is so less because I have considered a random data. That's why. But if you consider some kind of realistic value, you will get some good amount of final current. Okay. And if they only ask to calculate the current expression I of t, then this will be your answer. But The moment I am entering the 2 pi value, it is giving so less value. But in this question, I had intention to explain how to proceed with such problems. Hope it is clear to you. And if you have any doubt regarding this discussion, you can ask me in the chat box. Thank you.